All right, so let's check out this Khan Academy assignment, sinusoidal models and word problems. For all of these problems, usually you'll need a couple of things in order to solve them. You have to figure out first what the period of the function is, and then you also might want to know the general shape of the graph, really just in terms of the midline, the maximum, and the minimum of that graph. And if you know those two things, you can pretty much solve any of these problems in this assignment. So I have a few sample problems here. We'll just look at a few sample problems to kind of figure out how to solve these. All right, so this problem says we have a function d of t that models the distance in thousands of kilometers from the Earth to the Moon t days after the Moon's perigee, which is when it's the closest to the Earth. So it sounds like we're starting at the point or the time when the Moon is closest to the Earth. That's like a minimum distance. All right, so and here t is entered in radians. So if we look at our function here, let's do those two things that I said. Let's first find the period. So the period, let me write that down. All right, so for the period, all we have to do is take this term in front of the t. If you remember, the period is going to be 2 pi divided by that term. 2 pi over 29.5. That's going to be the period, right? And if we simplify that, the 2 pi's canceled out and the 29.5 flips up into the numerator, you get 29.5 is the period, 29.5 days. All right. Number two, let's figure out what the graph looks like more or less. All right, so for the graph of this, like what we said, the problem was kind of implying that we're starting at a minimum distance from the Earth. So, and even when we look at this function, we'll see that it does start at a minimum. All right, so let's take a look at the graph more or less. Is this gonna work? Yeah, this will be fine. All right, so what's the midline? Remember the midline is gonna be this 384, the number on the end. So the midline is gonna be up here at 384. Here's my midline, 384. We have a maximum and a minimum, right? That have to do with the amplitude in relation to that midline. So the maximum is going to be that 384 plus 21. And the min is going to be 384 minus 21, right? Which is going to be, what is that, 363 for the max? Oh, I'm sorry, I'm doing it backwards. 363 is the min, and the max is going to be 405. All right, so and also this is a cosine graph, right? So cosine always starts at the maximum or the minimum and then comes up and goes down, right? So for cosine, we're not going to start at the midline. That would be a sine graph, right? We're going to start at since it's negative cosine, we're going to start at the minimum. Right, and the minimum was 363. So we come down here. This is going to start at 363. It'll go up to 405. So here's my 363. Here's my 405. We can make little dotted lines for those two. Right, and we're going to start at the minimum. It comes up. It's the max. Comes back down. It's the min. Goes back up. It's the max forever and ever and ever. Right, so that's more or less what the graph looks like. Now let's look at the question. Just how many days after its perigee, which is when it's the closest to the Earth, does the moon first reach 380,000 thousands of kilometers from the Earth? All right, so how many days after its perigee? Well, the perigee is when it's closest to the Earth. That's the minimum distance. So that's this point right here, my minimum. So I want to figure out how many days after that minimum does the moon first reach 380,000 kilometers, thousands of kilometers from the Earth. So where is that 380? Now that I have the graph, where is that 380 in relation to these three numbers, the max, min, and the midline that I have here? It's going to be somewhere between the 384 and the 383. And it's the first time that we hit it is what we're looking for. So it's going to be somewhere right around here. All right, so I need to find that point. All right, so all we have to do is set our function equal to that 380. All right, this is not going to like this. So we're going to set our function and say negative 21 cosine 2 pi over 29.5 t plus 384. Set that equal to 380. All right, and we want to solve for t. So what we're going to do is try to get everything away from t. Let's subtract 384 on both sides. So you get negative 21 cosine 2 pi over 29.5 t. And then here, if I subtract 380 minus 384, I get a negative 4. All right, let's keep going. Let's divide by negative 21. So you get cosine of 2 pi over 29.5t is equal to negative 4 over negative 21. Right? And then we want the last couple things, we need to get rid of the cosine. Right? To do that, we have to do a cosine inverse. So to get rid of the cosine, when the cosine is gone, we get a 2 pi over 29.5t is equal to, we did cosine inverse to get rid of that cosine on the left. So cosine inverse is negative 4 over negative 21. And then last thing is to get rid of that, those numbers in front of the t, right? So we're going to multiply both sides by the reciprocal. So we get 29.5 over 2 pi times cosine inverse of negative 4 over negative 21. All right, and if we work all that out and put that into the calculator, we should get something. If we're rounding, it says round your final answer to the nearest whole day. I think you should get something, let me do that real quick. 29 divided by 2 pi, 0.5 divided by 2 pi times cosine inverse of 21. You get 6. It's about 6.475, which rounds to the nearest day, would round to 6 days. Would be your answer. All right, so notice that for this, all we used was the graph. We didn't use this period at all. All right, and that's okay because in the next few problems, we'll see we do have to use the period. So sometimes you do, sometimes you don't. The graph will always help out. Now, when we get to these problems where it asks you to find something a little bit different, then we combine the period with the graph, we'll see, to kind of figure out how to solve the problem. All right, it'll be very similar to what we just did, just a little bit, an extra little bit of thinking. All right, so let's check out this next problem. Actually, let's skip this one. I want to go to the one where we can use both the period and the graph. This one is going to be a really good one. All right, let's do the same kind of a thing. We have to find the period. All right, so before I even read the problem, I can do the period and I can say, what does the graph look like? All right, so what's the period? Remember, the period is 2 pi divided by whatever this term is in front of t, which is going to be 2 pi over 24. All right, and remember, this simplified, the 2 pi's kind of cancel out when we do this, and the 24 flips up into the numerator, and it's just 24 is the period. All right, the graph. What does the graph look like? This is a sine graph, right? So if you remember, let me erase this. If you remember, sine will start at, if we have a midline, it's going to start at its midline. It's going to come up to its max, go down to its min, and on and on and on again forever, right? So that's the midline. We have a max, and we have a min, and that's what the graph will look like. We just have to label these. All right, so what's the midline? That's the 15 on the end. So let's put a 15 here. What's the max? Remember, the max is going to be that 15 plus the amplitude, which is 12, and 12 in the front, which is going to be 27. So that's my max. 27. Remember, the min is going to be 15 minus 12, which is 3. So it goes all the way down to 3 and oscillates back and forth forever. All right, so now let's read the problem. We can kind of use this information to help us solve it. It says, Hungry Harry is a giant ogre with an appetite that fluctuates throughout the day. H.T. models the weight of sheep in kilograms that Harry would like to swallow 2 hours after he wakes up. And then here T is entered in radians. So here's the function that tells me how many sheep Hungry Harry wants to eat at any time T hours after he wakes up. So that means right here at T equals 0, that's when he wakes up. All right, I'm going to figure out what is the second time after Harry wakes up that he feels like consuming 17 kilograms of sheep. So this is where I look at the graph. All right, I'm going to figure out, well, when does my graph hit 17 for my along the y-axis, right? So where is 17 on my graph on the y-axis? It's going to be between 27 and 15, just after 15, right? So the first time he wants to eat 17 kilograms of sheep is going to be right after 15, right here. Let me do it in a different color. That's the first time. We're not looking for the first time, we're looking for the second time. So we're actually looking right here is going to be my answer, all right? That's when it's equal to 17. Right, and you notice there's actually an infinite number of answers, right? It could be over here, it could be here, right? It goes on forever. We want to find specifically the second time, that half starred right there. All right, so let's go about it the same way that we just did it in the last problem. What I'm going to do is take that function, and I'm going to set it equal to 17 and solve for t. All right, so we subtract this 15 on both sides. You get 12 sine 24, 2 pi over 24 t is equal to 2, because we subtracted 15 on both sides. Then we'll divide by that 12 in the front, and you get sine 2 pi over 24 t is equal to 2 over 12. And then we need to get rid of the sine. So we have to do, you can't just erase it. You can't divide by sine. That doesn't make sense. We have to do sine inverse. That's the only thing that gets rid of it. All right, so when the sine goes away, you get that bit that's left on the inside, 2 pi over 24 t is equal to, we did a sine inverse to get rid of that sine on the left. So you have to do the same thing on the right, and then solve for t. You get t is equal to multiply by the reciprocal, 24 over 2 pi times sine inverse of 2 over 12. All right, and now let's make sure that we get the same thing. I'm going to do this on my calculator. And remember, when we do this, it has to be in radian mode, or otherwise it will give you the wrong answer. I need 24 divided by 2 pi. I got sine inverse of 2 divided by 12. That's going to give me 0.6396. All right, so it's about 0.6396. Yes. All right. So that's the first time. That's this right here. Usually whenever we solve this first time around, it gives us the first value, 0.6396. I want to find the second value though. All right. Now this is where the period comes into play, because we can do a little bit of trickery here to figure that point out. Right. Where is, let's see, what is the period? It's 24, right? So if I start here and I go one full period, if I start from 0 and I go one full period, that means that's one full cycle before the whole cycle repeats again. That's going to be this star over here that I just put down, right? That's one full period. That's 24, all right? What is this value in the middle? Halfway is going to be what? It's going to be 12. Let's say that's 12 halfway, all right? And what we're looking for is this point just to the left of 12, right? Now, if we focus in just on this hill, right there we go. Focus in just on this hill right here. We can see there's symmetry here, right? All right, so remember what we found here. Oh, there we go. What we found here at this point, this distance here, this amount of time was the 0.6396, right? That's that distance. What I want to find is this total distance here, or this total amount of time. I know this total amount of time from 0 to here is 12, right? And because this is symmetrical, from here to here is going to be the same as from here to here, right? So this distance here is the 0.6936, right? And so then if I want, I'll do it in a different color. If I really want this distance here, this time here, then what I do is I take this total 12 and I subtract out. So I take this total 12 and subtract out this piece, the 0.6936. All right. So I take that 12 minus 6396. All right. And that's going to give me that second time when I hit the 17 kilograms of sheep. So 12 minus, and try to use the exact number that you got from the calculator. Don't use the 0.6396. It might give you the right answer that they're looking for, but try to use the exact number if you can. And if you do that, I get, it's about 11.36 hours later. After he wakes up is the second time that he feels like eating 17 kilograms of sheep. right? It says round your final answer to the nearest tenth of an hour. So we'd say 11.4 hours should be the answer. All right, and then we'll see, maybe we can do one more. How long does it take? Yeah, let's do one more. All right, so let's do this one. Let's do the same thing. We're gonna do, first let's calculate the period. And the second we'll do what's the graph look like. All right, so what's the period of this? We take our number that's in front of t, right? We do 2 pi divided by that number, divided by pi is gonna give me my period. The pi's cancel out, you get 2 is the period. And then the graph, what does the graph look like? It's a cosine graph. And then cosine always, we have a midline, and we have a max, and a min, right? So cosine always starts up here at the max, and it'll come down and go up, and then down, and then up again forever, right? So that's cosine. And that's basically what this graph will look like. We just need to label these things. So what's the midline? That's the easiest. That's the number on the end, 65. So that's this number in the middle. And then the max is going to be, remember, it's going to be 65 plus 25. The min is going to be 65 minus 25. Right? So that's going to be 90. Goes up to 90 and it goes down to 40. So it's 40. Whoa. And that's 90 up there. Cool. So it goes back and forth between 40 and 90. All right, and notice I haven't even read the problem yet. I just looked at the function and did these two things, right? And this will set me up in a good place to solve this problem. So let's read through it. It says Lena is playing her accordion by compressing and stretching it, and the accordion's length in centimeters t seconds after it's completely stretched is modeled by this function, where t is in radians. All right, so how long does it take for Lena to compress the accordion completely and then stretch it back out to a length of 50 centimeters? All right. Accordion's length, gotcha. All right, so to compress it completely, that means that it's got basically a minimum length, right? So where's the minimum length? That's going to be down here at 40, right? So that's when it's compressed completely. When it's stretched out, is the farthest it can be stretched out, that's when the length of the accordion is the longest, when you have a maximum length, so that'll be up here at 90, right? So you can kind of think of this as like the accordion is being like stretched and then compressed and then stretched and then compressed, right? Over and over again is what this graph is modeling. All right. So how long does it take Lena to compress the accordion completely? So here's compressing completely. Boom, compress completely, right? And then stretch it back out to a length of 50. So where is 50? It's right here between 65 and 40, right? So here's my 50. Let's say that's 50. I'll do another little dotted line. And so we're going to compress it completely and stretch it back out to a length of 50 centimeters. So I'm looking specifically for that point right there, that time. That's what I'm solving for. All right, so let's do it the same way we did the last couple of problems. We're going to take this problem here, 25 cosine. Actually, let me just do it like this. We're going to set it equal to 50 and then see what we get. All right, so subtract 65 on both sides. Let's solve for this. So you get 25 cosine pi t is equal to 50 minus 65 is negative 15. And then divide by 25 on both sides. Negative 15 over 25. And then we do a cosine inverse of both sides. All right, so let me write it so you can see exactly what's going on. All right, we're doing a cosine inverse of both sides. Is what we did in the last problems too. I just didn't write it out this way, but this is really what's going on because the cosine and the cosine inverse cancel out, and you're left with just a pi t. And then on the right, we have a cosine inverse left over of negative 15 over 25. All right, now solve for t, divide by pi on both sides. You get t is equal to 1 over pi times cosine inverse of negative 15 over 25. All right, and then we put that into our calculator. Make sure you're in radian mode. And what do we get? We get t is about 0.705, We'll say that. That's rounded. We don't want to use that value. We're not done yet. This is not the answer, right? Because that's the first time when it hits 50, which is actually right here. Right, so we just found this time is 0.705. Right, what I want to find is this total time here, though. Right, and this is, again, where the period comes into play. We said the total period was 2, right? Which means the period for cosine, the cycle for cosine, remember, like I said, it starts up at the max, and it'll come down and go back up to the max again before it repeats, right? So one whole cycle of cosine is going to be, let me do it in a different color. Here's one whole period right there. So that's a length of 2, right? So this time here is 2. I'm trying to find that red time, right? Let's see. So because cosine is symmetrical, one cycle of cosine, we're going to look at just this one cycle of cosine here. Cosine is symmetrical, this graph, right? If I know this distance here, the 0.705, then couldn't I find, I could say this distance here is the same thing, right? 0.705. And if that distance is 0.705, then this total, like if this distance here is 2, and this is what I'm solving for, this t, right? Then all I have to do is take this 2 and then subtract out that 0.705, and then I'm left with this t interval here, right? So 2 minus 0.705. Remember, like I said, don't use the exact, the rounded 0.705, use the exact number, just in case it throws off your answer. All right, so if we do that, we get, write it in the same color, 1.295 seconds. We want to round to the nearest tenth of a second, so rounding that to the nearest tenth will be 1.3 seconds.